Today, Boston Fusion Corp will present on Insider, or Inertial Navigation System Inspection and Detection of Evolving Roles. Insider is a system that detects subtle faults in inertial navigation system with higher accuracy and more quickly than human analysts. In this presentation, we provide an overview of Boston Fusion, the importance and challenges of reviewing inertial navigation system data for anomalies, and how Insider addresses these challenges. Boston Fusion Corp is a small business located in Lexington, Massachusetts. Boston Fusion is highly technical. 80% of employees have advanced degrees. Since 2010, we have developed and delivered revolutionary AI/ML scientific solutions to national defense challenges. We deploy the right AI/ML strategies to the right problems, such as sensor fusion software, computational social science algorithms, and interactive image classification. Currently, Boston Fusion Corp is looking for collaborators that have access to inertial navigation system data on different kinds of platforms, including surface and airborne vessels. With adequate training data, both synthetic and real-world, the value of Insider can be realized on a variety of systems. Condition-based maintenance of surface ships is a key priority for the Chief of Navy Operations, as explained at Navy West 2024, given by Secretary of the Navy Del Toro. The naval fleet of the future will need to be both responsive and cost-effective, and Insider addresses both of these needs. The Navy would receive a variety of operational benefits from moving towards more condition-based maintenance of inertial navigation systems. Condition-based maintenance requires monitoring system performance and identifying components that require maintenance based on their current state. It is a cheaper and more effective strategy than time-based maintenance, which mandates maintenance after a set duration. However, it also requires more time and expertise, as it depends on understanding system component performance. Navy vessels rely on inertial navigation systems, or INSs, to accurately maintain course. This is especially true in GPS-denied environments. When a boat returns from a patrol, it transfers the INS data into a secure room, and post-patrol analysts visually examine all the sensor readings from all sensors on all INSs. This process is tedious and results in a high false negative rate. The Navy would benefit from a faster method of identifying anomalous INS data to improve the operational availability and performance of vessels that use INSs. Insider's goal is to help analysts identify required maintenance on INSs before boats depart for their next patrol. This requires analyzing a greater coverage of patrol data, identifying anomalous readings with a higher precision and recall, and operating much more quickly than post-patrol analysts. Insider is a first-pass anomaly detection system for post-patrol analysts. Insider processes INS data at a rate of at least 31 days per hour on a MacBook laptop, 24 times faster than a human post-patrol analyst, and flags anomalies. In preliminary tests on real submarine data, Insider produced flags within every anomaly in the data. Post-patrol analysts use these flags to direct their attention towards the most important part of the entire patrol dataset. Operators identify more anomalies and spend more of their time on understanding root causes and conducting maintenance. Long-term use includes real-time anomaly detection and correction. Overall, these benefits result in cost savings and more accurate navigation. While Insider SBIR work focused on submarine data, the system architecture is agnostic to the types, numbers, and configuration of sensors. This means Insider can easily learn to operate on other systems and extend to other use cases. For example, Insider can be easily applied to surface vessels or airborne vessels and help improve navigation across the armed forces. To meet the Navy's needs, Boston Fusion has developed a tool called Inertial Navigation System Inspection and Detection of Evolving Roles, or Insider. Insider contains 2 machine learning-based anomaly detection pipelines, and users can choose to use one or both pipelines. The graph-based pipeline on the left in the figure explicitly represents expected relationships between sensor information and monitors how those relationships change over the course of the run. The attention-based pipeline, on the right in the figure, learns implicit relationships from the data. This second pipeline is a faster black box model, while the graphical model requires more resources and provides more explainable results. Therefore, users can select pipelines based on their needs. In Phase 1, Insider produced promising results when tested on government-issued data and simulated anomalies. In Phase 2, Insider identified simulated anomalies 14 times smaller than in Phase 1. Further, Boston Fusion tested Insider on real data collected on submarines, with logs indicating the anomalies from real-time operators. Insider identified all anomalies identified by real-time operators, and additional anomalies that passed unnoticed. Importantly, Insider ran on an Apple MacBook Pro and processed data at a rate of 31 submarine days in 1 hour of processing time. In future work, the team will incorporate Insider into a post-patrol analyst environment. Importantly, the goal of Insider is not to replace the human in the loop, but to empower human analysts to understand INS data more quickly and comprehensively. In preliminary tests on a MacBook laptop, Insider processed data at a rate of 31 days per hour, 24 times faster than a human analyst. Insider has demonstrated performance on real data from submarines, identifying anomalies that passed undetected by real-time operators. Immediate transition plans are to install Insider at a post-patrol laboratory. Once performance on real data has been validated by real post-patrol analysts, the team plans to install and refine Insider on a test vessel, for example the USNS Waters. This long-term transition plan requires extensive work to ensure that Insider can run in real time. Insider can easily adjust to any system that uses INSs to navigate, and even adapt to non-INS-based navigation systems, such as GPS-based systems. Insider has been developed with assistance from subject matter experts at Lockheed Martin. Transition into an implemented condition-based maintenance tool requires additional development and testing by the end users. Boston Fusion is looking for transition partners who can provide different platforms for testing Insider. If your organization operates vessels that use INSs or other sensory systems to navigate, we would like to discuss collaborating. If you are interested, please contact either Dr. Mertens, the Insider Principal Investigator, or Dr. Winterton, the Boston Fusion Chief Research Officer.